So the reason that I drilled a 10mm hole through this is so that I can put a cap screw, you can just see it in there on one end, and then put a nut on the other end so that I managed to bolt this together. The reason that I've done this is so that where I've drilled the one, I can now drill this one and get it absolutely precise as to where the holes are, because I can use these holes as the guide for the drill through to the other side. So here I'm drilling one of the holes, so I'll get an accurate drill through both sides. So there are the 3 holes drilled in both sides using the 10mm hole that's on the inside as the guide for the bolt. Now I can drill these out and tap one side. So I'll put this back in just to neaten up the weld here. And if you remember, we put a 10mm hole through there. Now the reason that I've done that is for 3 things. One was to locate these 3 holes, which we've done already. The next thing is to hold these 2 together so that I can machine this, because if you try and put this in the lathe by just holding it on this narrow face here, it's probably going to get thrown out of the lathe by the tool tip, because it's going to jam. There's just not enough strength on this face to support while you're machining on this edge here. And the other thing that I'm going to use that 10mm hole through is something that I'll show you later. So the welds have cleaned up nicely. The part that I'm working on never jumped out of the lathe. The lathe tip never got broken, and so everything is all aligned nicely, cleaned up nicely. That 10mm hole served its purpose, and the bolt that goes through it. So here's the joint made up. Cap screws are in, just bolted up, temporary. Now we can look at welding this onto either end of the steering shaft. All looks true, strong. So just an example, if you try and hold this with this narrow face here in a chuck, and you put a lathe tool on there and you apply pressure, what's going to probably happen is this will come out and it'll fly to the wall or hit you and then break the tool at the same time. So that's why it's not a wise idea to machine at that point there and clamp it with such a narrow face over here. So here's our famous 10mm hole. What we're going to do with this one is we're going to drill this out to about 15mm, and then I'll show you what we're going to use it for. So we're going to drill this 10mm hole out to about 15mm. So here is the final little trick with this 10mm hole, which has been so useful. So we've drilled it out to 15mm over here. But if you try and weld this, it's very difficult to get a good weld there. It's just not going to work. So what we've done is I've chamfered this so that we can get the welding torch in there much easier and perform a far better weld on this sharper edge than you can trying to get down into there. So this is ready for welding, and you can see that because it's got a chamfer on it, it'll be so much easier and a much stronger weld. So here I'm using a dial gauge just to check how much out of a line this is. so that I can just straighten it and get it within spec, so that the steering shaft is straight enough to go between the bearings properly. Here's the first part of the steering column. This bearing block has really made a big difference. You can see just how easy this turns. I'm turning this whole first part of the steering column. You can see it goes up to the actual steering wheel there, and it's easy enough just to turn by hand. All balanced, all strong, looking good. So the bottom bearing is clamped in. I'm going to weld this onto the bracket that's bolted to the chassis. It seems to turn fine. The wheels are turning a little bit, doesn't seem to foul up. Everything looks straight, intact as it should. Here's the bracket made up to take the lower bearing and the lower steering shaft, so I can paint that now and fit that in. So here's the steering column and shaft finished. You can see it goes down here and it carries on there into the bearing, and it rotates like that. Now there's two things here that we need to take note of. Is this joint here. Normally a joint of that type is called a rag joint, which is similar to this. It's got a rubber connection. It's just for vibration mainly, but because I've got this between a bearing here and a bearing there, it's got to be a solid joint. It's not advisable to have a flexible joint between two bearings. And these are self-aligning bearings, so they can turn themselves in this point here as well as turning this way, rotating there. So they can turn in that line there and in this line here. The other thing is that if you're going to join something like this, you need to put your joint to one side. It's better not to put it in the center. And the reason for that is that if you do have a bit of run out, you've got length to adjust that run out before it gets here. So it's smaller at that point if your joint was here and you had run out there. So that is why I've put this joint at a higher up point. So everything seems to work fine. So this has been quite a tricky job, mainly because of the degree of accuracy that I've had to use to try and get this to be all correct. Well, everything had to be aligned with the bearings and so on. So just to go through it, I've made up a bracket which is over there. That leads up to the bearing block, which is over here. And these are self-aligning bearings. This comes down the shaft to this joint that I've made here. Then it comes down this shaft all the way to the next self-aligning bearing, and then it goes through to where the steering rack is down there. I don't know if you can see it. Might be better if I pulled it across here, but that's where the steering rack is. So overall, quite a difficult job, but working very well. So here's the steering shaft all in. Everything's working really well. I've got the wheels jacked up off the ground just so that I can test it out, but doesn't seem to be any problems.